and today I'm talking about citizen data science with Home Assistant. My own background, actually, I come from a scientific background. I did a PhD in physics, and I was basically building experiments that would study man-made crystals. Okay, so just to give you a brief overview of what I'm going to talk about, I'm first going to introduce the topic of the smart home and smart hubs and answer the question, what are they and why should I care? I'll then give a brief introduction to Home Assistant and tell you why I think it's a great platform for doing citizen science. Then we're going to have two case studies. I'm going to present the first one, and that's on a bird classification project I've been working on. Okay, so is that working? Okay, yeah. The first topic, smart home and smart home hubs. What are they? Well, to start with, there's a few more people coming in. Let's give them a chance. People are buying all kinds of connected Wi-Fi devices, like Wi-Fi connected light bulbs and other kind of smart things that they're putting in their home. This ranges from quite simple things, things that you toggle on and off with a remote control, through to more sophisticated smart devices. A nice example is this learning thermostat, and this basically learns your habits over time and adjusts the heating in your house to save you energy. So for instance, if nobody's home, the heating will go off and it'll save you some money. So typically, people will start buying these things and the home maybe starts filling up with a few of them. And what they really want is a hub to centralize control of all those different devices. So you've got a few commercial ones out there. And the obvious one is Amazon Alexa. Does anybody in this room have an Alexa? Okay, so quite a few people already. There's a couple of other ones. So Google, they come to the game a bit later on, but they got their Google Home. And Apple have just released this, 6 months ago now, this smart pod speaker, which basically is a smart home hub as well. So these are great services, great toys, but they're a bit limited in terms of how you can actually access the data that they're capturing. So if you've got a dozen devices in your home, this thing is aggregating that data in some way, but you have no way of actually getting to it. They've also got privacy concerns. So there was a recent article in the news. This Alexa inadvertently sent somebody's private conversation over the web, and it ended up in somebody else's home. So there's a couple of things, concerns people have about these commercial solutions. I want to do a bit of sort of future prospecting as well, like we had in the previous talk, and just sort of speculate for a second, what would a future smart home be capable of? Well, I think there's a number of things that we'd like it to do. We'd like it to have routines, which can save us time, energy, or money, a bit like the learning thermostat. There's a couple of problems, challenges you have when living in a home that I think a smart home would be really good at solving. One that I've identified is non-invasive monitoring. So let's say you have an elderly relative and you're a bit concerned about their welfare, but you don't want to invade their privacy by sticking cameras in their home. The question is, can you come up with some kind of system which can sort of monitor them, give you that reassurance, but not invade their privacy? And I think a smart home might be one way to do that. Another idea I've had, which is actually inspired by an episode of Black Mirror, which is a really great TV series, you have to check it out, is this idea of the home learning your personal preferences over time. So what actually happens in that episode is a smart home learns how the person likes their toast, and so they get a perfect toast every time. But you can imagine it learning different habits for different people. So these are just a few of the ideas, and I think it's going to be probably people with a data background, maybe even Python data scientists, that are going to drive some of these developments and innovations. But what we really need is an appropriate platform to try these ideas out. So that's where Home Assistant comes in. What is Home Assistant? Well, it's an open source home automation hub. It's written in Python 3, and it runs totally locally. So most people have a Raspberry Pi in their home that they're using to run Home Assistant. This is also a very popular project on GitHub. Right now, it's got over 14,600 stars, and it's growing at an impressive rate. We've got a very active community as well. So based on regular downloads, we think there's at least 60,000 regular users of Home Assistant. If you want to check out the docs and get a feel for what Home Assistant looks like, head over to the website. I've just got a screenshot of it over there, and you can see the URL at the top. So the next question is, what can you do with Home Assistant? Well, it's a smart home hub. So what it's really great at doing is linking together different services, allowing you to control them all from a central place. And you can then set up very advanced automations to do routines. I've got a screenshot over here just of some of the main sort of high-profile integrations that are available within Home Assistant. So it actually started out with the Philips Hue smart light system, but it now supports like the IKEA system. There's also integrated media players, so you've got the Plex media player in there, and other kind of web-based services. So like Dark Sky is an internet weather service. Okay, so the next question is, you're curious about Home Assistant. What do you need to get started with it? Well, you don't need an awful lot of money. I reckon that you can pick up a Raspberry Pi for £10, put it in a case. You're talking £15 worth of hardware. If you've got your own power supply and an SD card, then you're ready to go. So the setup process is pretty straightforward. What you would do is just head over to the URL there, download a disk image. You then flash that onto the SD card. And then an optional step is to set up some of the configuration for the Wi-Fi, for instance. You would basically just edit a text file on the SD card, plug the SD card into the Raspberry Pi, give it about 20 minutes, and it's going to connect to the internet and download the latest updates to Home Assistant. And then it's going to start a little web server, which you can access via this URL over here. It's got a really neat auto-discovery system. So it sort of scans your network, and if there's devices that it can control, it will pick them up automatically and give you a nice sort of step-by-step prompt to configure them with Home Assistant. Once you've done all that, you can start exploring and configuring extra services, like the web-connected services, and customizing the look and feel of Home Assistant and creating automations. Okay, so I've said it starts a web server. So what is the UI? Well, it's accessible via the browser, and basically you get a panel. This is the sort of out-of-the-box interface to Home Assistant. You can see across the top here, we've got some sensor readings. These are just numerical readings. But we've also got cards over the front face of Home Assistant. And these are showing controls to switch on devices that have been connected to Home Assistant. You've also, in this case, this guy is displaying a media player. So this gives you a very standard way to look at Home Assistant. But the great thing about Home Assistant being open source is you're not limited what you can do with it. So you can completely customize the look and feel of Home Assistant. There's this really neat project on GitHub, and it's called Floor Plan. And what people have done, they've taken all that data and they've put it onto a 2D map of their home. So this guy over here, this is a real-time image that updates. So what you're seeing on the graphics there are sensors he's got in his home. And if, for instance, the door opens, the door will actually open in real time on that display. So it gives you a really neat way to know what's going on in your home. This guy's also got his camera feeds over there and some other weather data. And I believe that the way he's displaying it is via a tablet on a wall, probably in his living room or something like that. But the point is, there's lots of creative people out there trying new ways of interacting with a smart home. Okay, so this is a talk about citizen science and data. So the question is, how do I view the data that Home Assistant is capturing? Well, it actually gives you a standard interface to look at the data that's being recorded in the database via this history tool. What you can see across the top there is categorical sensors. So, for instance, binary sensors that are on or off. And then below, we've got sort of numerical sensors. So in this case, he's got, I think, some temperature sensors, and it's just a time series plot of the data they're capturing. But like I say, because Home Assistant's open source, you're not limited in the way they actually view the data that's being captured by it. And a real neat development of Home Assistant is this idea of add-ons. So basically, you have a kind of web store inside Home Assistant where you can, with a single click, install other services on the same Raspberry Pi and automatically configure them and link them in with Home Assistant. One of the popular add-ons at the moment is this InfluxDB and Grafana add-on. I don't know if you know about InfluxDB, but it's a very popular time series database in Internet of Things. And so basically, you'd set things up so that Home Assistant would plumb its data into InfluxDB. And Grafana is another tool, but it allows you to build dashboards that look at data within databases. So this guy is actually configured, I think he's showing his download speed on the speed dial at the right there. And then across the bottom, you've got some other sensor data. But the point being, you can actually create really nice visual ways of looking at the data you're capturing without very much effort at all. So while we're talking about add-ons, I just want to briefly mention an in-development add-on, which is that of a Jupyter Lab server. So if anybody's a data scientist, they're probably working with Jupyter Notebook some of the time at least. My idea here is how do we get people doing data science that wouldn't ordinarily fire up a Jupyter Notebook and start looking at data they're capturing. So what we're working on is an add-on which will allow you to create a Jupyter Lab server with a single click, and that will all be linked so you can automatically get the data from your database on Home Assistant. So that's a work in progress, but I think that could be really neat. Okay, so we can get a little bit more technical now, seeing as we're talking about data, and I just want to give you an overview of the backend that Home Assistant is using. So it's using a standard SQL database. Out of the box, you get a SQLite database, but you can change that and use, MySQL or whatever else you want to do. This is great because it's a standard tool, and you can use, SQL queries or pandas or even R to, look at the data that you're capturing inside your database. I actually wrote a small package called the Hash Data Detective, which provides a bunch of convenient functions to help you parsing the data out of the database. And I've got a plot that I created using that package down at the bottom here. This is just a time series plot showing, well, I think in green, the outside temperature, and then in red, just the temperature in my home. But this is really simple to do. And it's on PyPy, so you can install it pretty quickly. And I was playing around with it the other day, and I wanted to know, could you collaborate with other people online on analyzing your data in Home Assistant? And I picked up this tool, Google Colaboratory. Has anybody else tried that one? No? Okay, well, basically it's one guy, but basically it's like a Jupyter notebook server that's running on one of Google's servers. And it's pretty neat if you're looking to get into sort of deep learning and stuff, because actually with a single click of like a drop-down menu, you can start using a GPU, and you get 12 hours free usage of that. Anyway, the point being, it's an online environment with basically no setup, no install, with a lot of potential. And you can analyze your Home Assistant data online in that way using, well, the tool that I wrote. So check it out. Okay, so while we were talking about data, I wanted to briefly talk about different ways of getting data into Home Assistant. And I think we've got a couple of people here that are interested in MicroPython. Is that right? I saw one. Okay. So there's lots of different ways you can get data into Home Assistant, but I just want to focus on the ways you might do it, maybe from MicroPython or from one of these micro boards that run MicroPython. The first way you could do it is a physical connection. So if you're running Home Assistant on a Raspberry Pi, it has these GPIO pins, and you can literally plug wires and sensors into Home Assistant, and you could use your MicroPython board to sort of stream data in that way. Another way you can get data in is by using the REST API that Home Assistant creates. So just using standard web calls. Another protocol that's supported is MQTT. And this is a very lightweight messaging protocol that's particularly popular with the Internet of Things. And actually, this is the approach I used when I wanted to integrate a MicroPython board into my Home Assistant setup. So I bought a flat last year, and I upgraded the boiler in it. It was supposed to be brand new. Within 6 months, this boiler started leaking, and this was really annoying. I was getting messages in the middle of the night from my neighbor to say there was water coming through the floor. So I wanted to create a sensor that would tell me when this thing was leaking, capture more data about when the leak was happening, and hopefully in that way figure out what was wrong. Because I had a couple of engineers came out and said, well, there's nothing wrong with the boiler. We can't see what's wrong. So what I did, I used one of these MicroPython boards. In this case, I chose a PyCon board. And I put a temperature sensor on it and a moisture sensor. And what you can see in the image over here is this is my boiler, and this is a temperature sensor on the side of it, and that's the moisture sensor down there. I wrote some MicroPython code that would ping regular readings from these sensors to my Home Assistant using the MQTT protocol, and I had a little real-time display on Home Assistant of the readings. So I ran this and had a few more leaks, and I noticed that the leaks, they were always happening when I wasn't home, but they were happening exactly 5:15 p.m. And this is such a specific time that with the engineer, we were able to figure out what was basically causing the leak. So we solved it. I haven't had any problems since, so that's great. So this is an example of using data to solve a problem you have in the real world. Oh, and it's all Python as well. So. Okay, so that's my introduction to Home Assistant. So like I say, we're talking about citizen science, and we have 2 case studies. And the one I'm presenting today is a project I've been working on very recently on bird identification. So my mum, she's really interested in bird watching and sort of bird life. And she bought me this bird feeder, and it's got suction pads, and you can stick it onto your window. So I stuck it onto my window at home, put some seeds in, and pretty quickly had birds coming to my window. Because this is over winter, the birds, they're very hungry, so we had a lot of activity. It was really fun to watch. It turns out there's all these sort of science studies that are run by organizations like the RSPB, Royal Society for Protection of Birds. And what they ask people to do is to watch their bird feeder and then write down the birds they see coming. And then at the end of however long this project runs for, 3 months or so, they send in that data, and we can get a picture over the whole country of what's going on with the bird populations. Well, I thought, well, I've got Home Assistant, and I like to learn about new technology, so why don't we see if we can have Home Assistant automatically capture images of these birds and preferably classify the birds that it's seeing as well. So what I did is I purchased, in this case, a £10 USB webcam. I plugged it into my Raspberry Pi 3, which is running Home Assistant, and I stuck it on my windowsill pointing at the bird feeder. And this is a typical image that I would capture. I used one of these Home Assistant add-ons to set up a motion detection system. So the camera, when it detected motion, would take an image. The only problem with this system is motion triggered systems, they're not discriminative. So even if there was a funky light effect or a plane in the background, it would trigger the motion capture. And I ended up with literally hundreds, almost thousands of images. Probably less than half of them actually had a bird in. So this obviously was not going to work as an approach to quickly gather images just of birds. So really the first challenge was what kind of classifier can I use to sort out the images with birds and those without. So this is an image of a bird, this is one without a bird. And I had a look online. I've been just generally interested in learning about deep learning and image classifiers, and I found a really neat tool. It's a really simple to use machine learning in a box, they call it, by this company called Machinebox. And those guys are actually based in London as well. I think the whole thing's written in Go, actually. But basically, there's different machine learning models, and they run inside a Docker container, and they expose the model via REST API. So this is everything that I needed to get started integrating this into my project. So basically, I had 1,000 images, and I physically sorted them, 500 with birds, 500 without birds. I practically got RSI sorting these things into 2 folders. It took a while, but nevertheless, I used one of their training scripts to then post these images to the classification box, which is what they call their classifier. And you do a test train split, and the classifier came up with an accuracy of around 90%, which really surprised me. It was pretty good. I guess probably the reason is that actually classifying the non-bird is pretty straightforward, but one of the things I wanted to get from this process was learning more about how you actually come up with accurate image classifiers. Okay. So the next task was integrating that into Home Assistant, and I've got a diagram showing how I've gone about doing that. So on the top left, I've got my USB webcam. There's motion, it captures an image. Home Assistant I've got running on a Raspberry Pi that has a component which detects when an image has been saved in a folder, and will then post that image over my local network to Machinebox, which has the classifier running in Docker. In my case, I'm running that on a local server. I'm actually running on a Synology. That would perform the classification and then return the result to Home Assistant. Home Assistant then, I have an automation which says, if the chance that there's a bird in the image is greater than 80%, send me that image. So that's what happens. If there's a bird in the image, it posts the photo to my phone with a notification. This is quite a funky image. You can actually see I think it's a robin or something, leaping off the bird feeder and heading down towards the ground. So, yeah. I wrote some custom code to do this, and if you're interested in this project, the URL for the GitHub work is down below. So that brings me on to my final slide for this bit. What's the next steps for this particular project? Well, I'd like to see, like I said, I want to learn about image classifiers. So I want to see if by curating the images that I use to train a classifier, can I improve the accuracy? Can I get it up to 95% maybe? After that, I want to also be able to discriminate by species, because I have probably blue tits, robins, magpies, even parakeets visiting this thing. It'd be great if Home Assistant could say, hey, there's a parakeet with a 95% probability, and I could start to actually gather data that would be directly relevant to that birdwatch study I mentioned earlier on. Obviously, I'd like to contribute this data to that study as well. And, well, my next task is to integrate Classification Box into Home Assistant so it becomes really simple for anybody that's familiar with Home Assistant to start using it. Another idea I've got is how do we share this work with people that don't have a technical background. My mother, for instance, wouldn't really know about image classifiers. So my idea is probably to publish this work somewhere, maybe on Hackster, make the classifiers available, provide all the scripts that I use just to set things up, and then anybody with a budget of about 30 or 40 pounds will be able to reproduce this work. Finally, I need to make my bird feeder magpie proof, because I've had a real problem recently. Magpie has discovered that by it's too big to actually get on the bird feeder. So what it does, it clings on with one leg and sort of scrapes up the window with the other leg and starts pecking away through the hole to get the food. And it's actually ripped the bird feeder off the window several times now, and it has a hole in it. But I captured this quite interesting. You can see the magpie having a feed, and it's actually managed to almost yank the bird feeder off the wall. This blue tit has come along, found that it can't feed in its regular way, flown around for a bit, and then discovered it can actually feed at this hole over there. So this has been quite a fun project overall. So that's my project. I'm now going to hand you over to Oliver to talk about pollution, personalized pollution management.